calories last year.
Okay.
I thought I could make it by sorry.
Okay, all right, real quick. We're gonna go through your test. Nothing in front of you right now. You get to look at your test scores. And then we'll get to any questions you guys have about the question that I have and whatnot. Now, I do want these tests back. They're not yours, they're mine. I want them back in case you decide that you want to retake, because everyone always has the option of retaking. Remember, if you're going to choose the retake option, you get the better of the two test scores, so it's no risk to you. That's what I always do, because I'd rather have you retake and then worry about your grade. Other thing that I want you to always think about is that if you're going to choose to retake, it can be for any score. You don't have to just be failing to retake. It could be an A-, you're just not happy with it. That's fine, retake it. If you did fail, I don't know if anyone did. If you did, you have to retake. I'm not allowing you to choose to fail. You have to retake, and you have to come in here in the morning or after school to do a retake with me. Okay? You'll have to come in and spend minimum 10 minutes with me to go over the problems you missed, talk about why you missed it, what you need to know. Then we'll set a date for you to retake once we're done with the review. Maybe you don't review over one day, you review over a couple, because it's your choice. That's fine. But we'll set a date for you to retake, and it has to be before or after school. It can't be during like a class, like my class and stuff. So you'll have to do it on your own time. Okay? All right. Questions at all about retake policies? Now it can be during like one of your study halls, so that's fine too. I'm okay with that. So because you can come in here, I have an office, you can just sit in there and retake. Okay? Okay, we good? Everyone's comfortable? Okay, let's talk about scores. So it's out of 61, you guys saw that at the top of your page. Let's go through number one. Number one is worth 4 points. How I basically grade it is it took 4 lines of work to actually do it. That's how I always work it. It's better to show work and get it wrong than it is to just get a wrong answer, like no work at all. Because you get points for at least showing me something. 8 minus 6 is 2. You cube it, which is 8. You have to take the 5 times 8. I think somebody in here did the 6 plus 5 first, and then took the times 8. That was kind of a mistake. You have to multiply before you can add and subtract last. So it should be 46. Questions on the first one? Okay, second one. Intersections and unions. Intersection is what they have in common. Well, when you look at the two sets here on number 2, the two sets, they share nothing in common. So your answer is the empty set. It's brackets with nothing in it. Or it's called the zero null set. It's however you want to call it. Okay, it's nothing. A lot of people are like writing all the numbers out. There was nothing in common. That's an intersection. It's a Venn diagram, the overlap. Union, it's all the different numbers you see. You did not have to put repeatings. So if you saw in your paper, some people did this, they put like 1, 2, 2, 3, 4, 4, 5. I crossed them out, like the 2s and 4s. You just have to list those numbers out. But I was looking for curly braces, and you're doing that. Okay? So if you forgot curly braces, I probably put them in there because you need them. Okay? 4. Oh, by the way, those were worth 2 points for the top one, because you had to understand that it was an empty set and how to write it. And then 3, there was 3 points on that one because it's every 2 numbers basically is a point. Okay? All right, number 4. You have to distribute. The only mistake I saw in this one is somebody forgot to distribute the 4 to the -3. That was the only, I think, mistake in a bunch of different classes that I saw. It was consistent, like a couple of different people did. But you have to distribute, here's the get. You have to add like terms, so 20 minus 6 is 14. The -12 and -3 make -5, or -15, sorry. So there you go. There's 4 points. It took 4 lines of stuff. I just didn't show the first one where I had to distribute to everything. I just wrote down the answer. All right. 5. This is the most common mistake problem that I saw on pretty much both classes that took this. Negative sign was wrong. Because I know the inside you have a power of 3, right? So you have, -3 to the power of 3, which is -27. I understand that. But then you're squaring it. Squaring it gets rid of the negative sign. It's gone. So, because the 2 is on the outside of the parenthesis, it gets rid of the negative sign. You should recognize that right away. That was something I kind of like pointed out a lot during class. Like, if you have a certain power, it does cancel out negative signs like even powers do. And that's, now if you did differently, maybe you did like the 2 times 3 first, that's fine, that's a 6, that's still an even power, and -3 to the 6th power is still positive. Okay? Questions at all about how I got the positive 729? Okay. The way I did it was just to keep the numbers relatively small. Alright, 6, you have to distribute first. You can actually see the most common mistake people made, they didn't distribute correctly. When you distribute the powers, you have to multiply the powers, like 4 times 2, or the y to the 2nd. So that's where I'm getting this 8 and this 2. And then the 21 and the 33 because you take the 3 times. The common mistake I saw is a lot of people are just adding the powers. You add powers last. When you distribute a power in, that's when you have to multiply it. And the answer should be negative. A lot of people forgot the negative sign because you do have a -6 to the power 3, which is still negative. But you have the 5 to the second power, -5 to the second power, which is positive. So in the end, you will get a negative number. Then you just had to add the powers last because you throw them in the back. I warn you, you're going to have something like that on practice essays. I said that very clearly. That's what if I put powers there, hint, 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 hint. 7, you have to distribute the powers. Here's the funny thing. People are distributing powers in 7, they're distributing all correctly, multiplying, but then they still miss the distribution on this one. I couldn't understand why you did it here but not there. It's the same type of problem. But distribute, multiply the powers, you can see what I did on mine. I didn't simplify it all first. Some people chose to simplify it. It made your problem a lot easier if you did that. I think I even said that as a hint. So you distribute. But now that you have this, noticing that you're going to get a negative number because it was power 3, so your answer should be negative. Some people forgot that. Okay. The B's and A's, you have to move them around. A is simplified to be 9 on the bottom, 30s are on the top, you have to move the 6 up. Okay, questions. Here, get rid of the phone, thanks. Yeah, perfect. All right, we're good? Moving to the second page, it was out of 25 in the first. And again, if I mark something wrong, let me know, but I'm pretty sure I did. So, I took my time going through those. 8, you had to move the power. The most common mistake on these was forgetting the negative sign on number 9, which you're lucky I didn't count that wrong. I just probably circled it. That would have been another point for you. But the other mistake that I actually counted wrong is people put the decimal in the wrong spot. Like you had to move it all the way to the front and then put a power of 7, or all the way behind the 4. It always has to be behind the first digit on the left. So when you go to the leftmost side, the decimal has to be behind the first number. That's proper scientific. Some people are just moving to the first number they saw. It's the farthest to the left. So that would be behind the 4 and behind the 1. The number on the left, ignoring zeros. Okay. All right, there are 2 points each because I want to see where you put the decimal and was your power correct. Some people only missed 1, but you're lucky if I didn't count that negative sign wrong. I just circled it. 10. 10. You had to multiply the 2 together. So you get 12x to the third, but then you had to simplify. If you read the directions, it said simplify. You have to go all the way. You can't just stop at 12. You only did half the problem. So 12 breaks down to 2, 2, and 3, and then 3 x's. You have to circle the pairs, kick them out because it was a square root. So what I get is a 2x and a 3x. You can see where my math comes from. Some people got lost in the process of multiplying. The number 11, you can divide these. 50 divided by 10 is, 500 divided by 10 is 50. The x to the -1 goes up and becomes an x to the 4th. So there's really no fraction. But you still have to simplify. That's still a part of the directions. So if you simplify, you had to break up the 50 to be 2, 5, and 5. There's 4 x's, you circle the pairs, you kick them out. So there's your answer. You would not believe how many people, they multiplied both the bottoms by the root of square root of 10x to the -1. Fine, you did that. But then you didn't simplify, so you missed points, because you didn't go further. Some people really butchered it. They didn't go anywhere they were supposed to. You have to simplify it, even the top. 12. 12, you can't just subtract these. You can't just add and subtract random radicals. They have to be the same radical for you to add them or subtract them. 50 and 8 are not the same number. So you have to simplify. You're actually seeing my math here. I broke up 50 to be 2, 5, and 5. The 8 is 2, 2, and 2x. I kicked out the pairs, so now what I have here are similar radicals, and now I can add and subtract them. Because I kicked numbers out, they have the same radical in the back, so you can add and subtract the front number, which is 3. Okay, on the next one, I had to simplify this. I can't just subtract this and say that it's 48 or whatever some people are putting. What you have to do here is you have to break these up so you can actually see what I'm doing here. The 54 is that back there. I kicked out pairs, or triplets I should say, because it was a cube root. And I did count it wrong if you drop the cube root symbol. As I said that you went to a square root, I do drop it out. You can see I put my 3's in there. But I kicked out the 2, kicked out the 3. When they go out, they're still multiplying. Everything's still multiplying there. So the 3's out front. The 2 went out front and joined the 5 and made 10. And when you subtract, you get 7 cube root 2's. And it's over there. It's behind the 7. You got to cut off. Okay. Good on 13. 4 points each, because there's 4 actual things I'm checking. I'm checking each one, how you're doing it to get to your final answer. Okay. Still right there. 14. You had to multiply by the conjugates. The only mistake I saw in this one is some people didn't choose the conjugate correctly. I saw a lot of people putting plus signs on the bottom, like they're multiplying by root 5 plus root 3. It's a negative, that's what a conjugate is. And I told you that conjugate on Friday. So you FOIL, first out and last, you can see my whole bottom. Normally, no, people would not write that, but I wrote out the whole bottom when I FOIL first out and last. The top just distributed, but the bottom, the 15's canceled. And then I took the square root of 25 and the square root of 9, and those actually divide to make, or subtract to make 2. So there's a 2 down here, and then you can divide each by 2. Now you didn't have to do that, but I was checking to see did you even get to the right fraction in the first place. Because some people weren't getting to 2 down here. You had to like try to get further than that. So I divided both by 2 because it was a single number, so you can divide the 6's by 2's. Okay, all right, let's move on. 15. All you have to do is add and subtract. I'm happy to say that no one tried to FOIL that whole mess out. So no one like attempted to FOIL out like a huge thing. The most common mistake that I saw people made was they distributed and they forgot to change certain things to be negative versus positive. That was the only thing that I saw. So you can see kind of my work here. So I distributed the negative sign to the back, so it's negative 5, positive 9, positive 8, negative 11. Combine like terms, so the 17 and then 5 combine to make 12. The 5 and the 9 make a 4, the 4x and the 8x make 12, and then the 3 and the 11 make 14, and it was degree 3. I warned you on test day, do not forget to write the degree of it, it's in the directions, I even circled it, and I even said, hey, you should probably circle that when you're doing it, so you don't forget, people forgot. Moving on, 16, you had to use Pascal's triangle. I even drew the triangle in there. Because Pascal's triangles, you start with a 1, go 2 1s, and then the next row will have 3 numbers. The 1s are on the outsides. The middle number is always made from the 2 added together from the top. That's how I'm making these 3's in the middle. How I'm making the 4, the 6, and the 4, and the 1s are on the outside. This is the row I had to use. So I actually did this on the fly. You guys had the luxury of having that big triangle in the back of the room. But I'm using that 4th row, the degree 4 power. So I split up all my 5x and 6 amongst these numbers. So I put a 5x and a 6 behind this, 5x and a 6, 5x and a 6, 5x and a 6, and a 5x and a 6. You can see them all right there, random in. So I could use that little space that I had. I put the powers counting down for the 5x's, powers counting up for the 6's. Notice that there's parentheses separating. I don't have 5x plus 6, it's 5x and then there's 6 behind it in its own parenthesis. Powers count down, powers count up. I did the math, 5x to the 4th is 625x to the 4th because these just cancel out basically. 5 to the 3rd is 125 times 6 times 4 is 3,000, x to the 3rd. 5x squared is 25, x to the squared is 36 times 6 is 5,400, and that's x squared. 6 to the 3rd is, what is that, 216 times 5 times 4, which is the 4,320. X to the 1st, and then the last one is 6 to the 4th, which is, I think, 1,295 or something like that. 96. Okay, there you go. There was 5 points. I did mine as fast as I could. Some people were complaining I didn't give enough space. I did mine 2 lines. And it's not that I'm a genius. It's not that. All I had to do is write up the numbers, put powers, and then just type it in a calculator. It shouldn't take you any work. It was only 4 stuff. 4 things you had to write. Okay? So it was 5 points, but if you actually wrote down every step, I was looking for lots of different things. You did not have to put the triangle on the thing, but you have the triangle in the back of the room. All right, 17, 18, 19, you had to factor completely. You had to factor this thing up as far as you can. You would not believe how many people wouldn't go further. Okay, now, I was not expecting people to go that extra step like I did on number 17. I was expecting to see this part, where you took out, here you took out an x squared from each of these, so that's x plus 6. Took out a negative 2 from here, so that's x plus 6, if I took out a negative 2 from both. They both had the x plus 6, so I pulled that out back. The x squared minus 2, that's what I expected to see. You can go further, that is the difference of squares. Even though 2 is not a square, you can still break it up into 2 parentheses, you just use square roots. That's how you can do it. You did not have to go that far. But I was expecting you to get to that one spot. 18, you have to take out a 3y squared. When you take out a 3y squared, you have to be left with a binomial. Somebody didn't do that. The thing that's left in the parentheses when you take out a common factor has to be the same size as what you started with. So when I divide out a 3y squared, 48 divided by 3 is 16, y squared is left over because I took out 2 of them. When I divide this by 3, I get 1, took out the y squared, so there's no variable, and that is minus sign. This is a difference of squares, and you have to keep going. You had to keep going. I counted it wrong if you did. That is a difference of squares. They are perfect squares. Expect you to go further. 19, the cube rule. You would not believe how many people still don't do the cube rule right. It's one small parenthesis, one big parenthesis. It's not 3 small ones. So, you have to take the cube root, take the cube root. Here they are. It's not an 8. The cube root of 64 is not 8. That's the square root. Cube root is 4. And the minus sign is here. The next sign is the plus, the opposite sign is plus. So it's always the opposite, then the same in the, or it's opposite, then plus in the back. You square the first item, you square the back item, and then you multiply these two together for the middle. People got like a bunch of points off, they didn't write the right parentheses down, or when they did write the parentheses, they weren't using any of the right terms. Because I can understand you have a small parenthesis, a big parenthesis, that might give you a point. The problem is you better have these items in the back. Whatever you pick, a lot of people pick like x minus 8. That was a common theme. If you had x minus 8, you better show how to use the x minus 8 in the back. X squared, 64 if you actually squared the 8. And then the middle term is 8x. Like you better have done those little things right, where you square the first, square the back, multiply the two together in the middle. Because I could understand you get the numbers wrong and you just commit to it. But people who didn't know how to do the back, they count that wrong and you miss like 2 points sometimes. Okay, I want these back. You can choose to retake if you want. Okay, so it's your outfit you're going to choose to retake. You don't need to warn me, you don't need to come in after school, before school. Okay? All right, want to walk around?
Is this
Question she added up then. 23,
What?
23,
What is this number?
14 is 6.
Minus 2. No, that's minus 1. Minus 1.
Okay.
So minus 1. Sorry.
I was gonna say, that
I
didn't
checked.
add up to
I
what
checked. It was a 1. It was 2. That's a 1.
You just wrote down the wrong one, right?
Boom.
He said he didn't get it.
And again, the reason I'm taking these back, if you're going to choose to retake, it's nice to look at what you made mistakes on, so we can actually like try to figure those problems out.
What's the... Can we retake your... I know Lee says
I don't know. I think I circled it. I was like, oh, that's wrong. And I'm like, oh.
Because like in chemistry, you can only retake one.
Yeah.
I think you were probably the first one I checked. I was like, oh, no, that's
Yeah, but it's not about grades. It's about
Because they got the last one.
take from it, man.
Okay. Let me start this up the camera.
It's blue. So, I think I like it.
Okay.
What was that?
All right.
I was the business dude.
The rest of the time today, let me get rid of this.
Sam,
The rest of the time today, we're going to take some notes on that. Actually, just turn that off. Okay, the rest of the day we're going to take notes on what the next chapter is going to bring. We're going to start with chapter 1. We're going to kind of go through some stuff. I want to make sure that everyone has the beginning notes saved. Today's the intro of the next chapter. Okay, we're not going to go too far in depth. The goal is to talk about stuff that you might have forgot over your years of geometry and algebra 2. Little things that I want you to know. Okay, so it's a pretty easy little day. We're going to take a few notes, and that's about it. Okay, all right, here we go. So we're on chapter 1.1. We're going to be graphing functions. Functions is kind of the overall topic in this next chapter. We're going to learn all the different strategies for graphing. I'm talking not just graphing linear stuff. I'm talking curves. I'm talking any weird type of polynomial. We're going to learn all the rules so that when I give you this crazy polynomial, something like this, you know how to approach that problem, what to do, what are the different strategies for how you're supposed to attempt to graph it without a calculator in your hand, or without a computer in your hand. Like the strategies we look at to graph that, if it's possible. Okay? All right, questions at all about what we're going to be learning throughout this chapter? Like that's the end goal. Like at the very end of the chapter, can you look at that thing, do all the rules possible and get a pretty accurate graph of where that thing's going without just guessing. Okay, because there's little basic rules, like little things. Like we're gonna start very short and easy on this first section. The first section talks about what a graph is, how to type it in a calculator, how to do just the little things that if you've never done it before, you know what you're looking at. There's gonna be some days we're gonna look at my graphing calculator, because I know that seems weird, but you do need to know how to use a graphing calculator, especially when you're going to college and you're forced to use one in like a upper level science course or a math course. And it's pretty painful when a kid says, I've never used one of these before, what do I have to hit? You should have learned it in high school. So that's what we're gonna learn this year. Now, I know a lot of you don't have a graphing calculator. They're super expensive. I told you even not to buy one because they're stupid. Okay? A lot of people have technology, you can just type it in, you can do that. But I want you to still know how to use one in case you're forced to. Okay, so that's what we're gonna be looking at. The goal today is to look at the coordinate plane, to talk about what that is. This is something you've seen since, I think, elementary days, or at least junior high. The coordinate plane. Talk about the different parts of it. Then we're going to talk about, after that, we're going to talk about the viewing window of it. And this gets us into our calculators. So, the viewing windows. So I'll try to show you my calculator here, so just so you can see it. And then the last part that I want to cover today is the table. So these are the different parts. I want to talk about the table. And again, remember, the goal today is just, this is light introduction stuff. Nothing crazy in depth. We're not jumping head first into like really difficult problems. The goal today is just to look, see the different parts, and understand what we're going to be doing. Okay, but those are our three parts. Questions of what we're going to cover today. Okay, we're going to use this stuff throughout like this chapter. So it's one of those things that just because we cover it today on the light intro day, I still want you to know it as we go through, the second section, the third section, fourth section, because they just assume you know how to use it. And it's just in the background. This is like the background knowledge you just need to know. So, coordinate plane. It's also called the Cartesian coordinate system. Cartesian coordinate system. Okay, if you've never seen the Cartesian coordinate system, I don't know what you've been doing since Algebra 1, because that was 90% of what you did in Algebra 1 was graph things on this, XY plane. This thing. That's the Cartesian coordinate plane. It's two number lines. That's all it is. It's just two number lines overlapping each other. One of the number lines is going this way. It's going horizontal, that's your X. So these numbers, this would be 0, this is 1, 2, 3, 4, and -1, -2, -3. It's a number line, right? And then there's another number line going up and down. So 1, 2, 3, 4, still has 0, then -1, -2, -3, -4. That's all it is. Now, traditionally you never see graphs that look like that, right? Because they have the whole grid system filled in, because all they did was extend all these little hash marks, and so that they're making the whole grid system. That's all they did, they just extend them. They're usually not there. Now, the coordinate plane is what we normally graph on. It's the easiest thing in the world. Everything uses it, including your phones, your computers, still use this. A smartphone, an Android, an iPhone, uses this system to plot points, and that's where the pixels light up. No joke. The more pixels on the screen, the more dense the screen is with pixels, the better the image looks, because it smooths things out. Apple always talks about retina screens, because they put more pixels on the screen so that you can't see the jagged edges where the lines meet. Because the pixels are smaller, and they can put more of them in there so that the letters look more smooth. That was one of the kickers with this year's iPhones, right? That they called it a liquid retina, or the Mac screens had an OLED screen, because there's how many pixels you're fitting. Okay?
Did you know that the iPhone XR has the same amount of pixels per inch
as the iPhone 4? Yeah, so that was one thing that most people aren't thinking about. That, yeah, if you didn't hear that, the iPhone XR, the cheap one that's coming out in October, like middle of October, the screen is like 320 by like 190 or something like that.
That's so bad.
That's really bad. In fact, you can't even play a 1080p YouTube video or Netflix video on that, because it doesn't have enough pixels to go full high definition
Why do they do that?
to save money, and they're charging you a buttload for it.
Yeah, like.
That
$800.
technology came out 7 years ago.
Yeah, like how much
So.
do you think it would actually cost them to make those
These
most expensive ones?
display panels, the panel probably only costs about $90 to make that, and they're gonna charge you $700 for that phone. Yeah,
Everything
as
else is
opposed
just-
to the iPhone X, the X's, right? Where they have like 1080
Yeah.
by 3200, you know, for their screen. Well, now there's more pixels to light up, so the screens look way better. Like there's gonna be a night and day difference. It'll look blurry versus smooth. And yeah, they're charging premium for the better one. They do that on purpose, okay? And they're saying like, and the thing is, most people will just say like, you won't notice the difference. From, you know, 5 feet away, yeah, you're not gonna notice the difference. But I'm not holding my phone 5 feet away. I'm holding it here in the middle of the night, trying to look up stuff in the bed, right? You're gonna notice the pixels, you're gonna see it's blurry. Because what you're doing here is this system. It literally has dots on a grid, and it lights them up with a certain color what it's supposed to be. But it's this system, right? It's right here, it's just picking pixel for pixel, and if you actually look at your phone, you can actually see the individual squares, the pixels, that are lit up, okay? Because of this system. In fact, if you go into like an art program on one of your devices, could be an iPhone, could be a Chromebook, it'll actually tell you where your mouse is sitting. Like in the corner, they'll have the coordinates, which is the coordinate plane. They're written like this. This will be in the corner of every art program, so you can go pixel for pixel changes. So if you need to go fix a pixel that's at 90 by 1000, you can go fix that one pixel. You can type it in, there's actually a thing where you can search for that pixel and color correct it. And you can get down to the nitty gritty. Now why it's written like this is called an ordered pair. It's called an ordered pair. It's an alphabetical order, X, Y. It's called a coordinate. That's what they always call it in elementary days. But it's an ordered pair, 2 numbers. The first number is right and left, the second number is up and down. How you always do it, X comes first, you have to figure out the elevator before you go up and down in it. Or pick a ladder before you can climb or go down it, that type of thing. You didn't believe how many people still get it wrong, especially when I throw zeros in there, negatives, they still get them wrong all the time. You have to be able in this class to graph on a coordinate plane. So if I told you the coordinate, 1, -5, where is that going to be found? So anyone happen to know where 1, -5 would be?
Yes.
Where would it be?
You want me to go up there?
Yes, just roughly the point where it's going to be put a dot. Boom. Okay, I agree. Make it bigger. Make it bigger. Okay, perfect. Right? That's a coordinate.
Kill her butt's wet.
Okay.
It's coffee.
All right. So let's call this. We'll call it C for D. All right. Good work. All right. So 1, -5. What that is? That's in a quadrant. So what I always say is like, hey, where's that found? That's in quadrant number 4. Okay. The quadrant systems. This is quadrant number 1. This is quadrant number 2,
Yeah, I don't like it.
3, and 4. Now, the reason why they go counterclockwise is because of how you draw angles in geometry class. I'm not joking, like that's the system that they use to draw angles. When you draw angles in standard position, you draw the horizontal line first, that's the initial wall. You open up counterclockwise to draw, and that's why it would land in the first quadrant versus if I kept opening for an obtuse angle, that would land in the second, then eventually reflex angles would be in the third or the fourth. So, but it's opening up like this when you draw your angles. They always go to the right and open up. That's why the number system goes 1, 2, 4. If you go to a foreign country, let's say you do a foreign exchange program, and you choose to go to a different country for a while, their systems are different. Like I had an Italian student a couple of years ago, when they came in, their number system was literally clockwise. They started with 1 in the same spot, but they went clockwise. That's just what their school taught. That's what their country taught. Because they were never using it with angles. They never related it back to geometry like the US does. They just said, okay, it's gonna go like a clock. So it was really tough for that student to figure out like why we're doing it until I explained the angles and it made sense. He goes, okay, that makes sense. And he just did it from then on. But it was just one of those things that says that's the way we describe it. Quadrant 1, 2, 3, 4. Now if you're in between quadrants, you're quadrantal. You're not on quadrant 1, 2, you're like in the middle of them. You know, you're right on the y-axis, that type of thing. Or x-axis. So just be careful of that. When we start getting to these crazy formulas like that one I wrote up on the board, you need to be able to like plot points. Now to plot points, you either have to set up tables to get all your numbers set up so that you can go and put them on your graph. and kind of see where it's going, do a kind of a plot point, you're gonna do a plot graph, that type of thing. And if you're on a calculator, you gotta make sure your windows are all set up. So that's why I have these two things written down. Is everyone comfortable with the coordinate plane though? That's a 16th century math concept, came out in the 1500s, right, by a French mathematician, René Descartes. We still use it, I'm not joking, it's used in every phone, every computer, the screen still uses it.
What they used before that?
For the screens, the dot matrix, we've always used it. We've used it since
No, like, just before these graphs, what they used before
they
graphs.
didn't plot anything like that. They didn't have a standardized notion of plotting. So that was that was a newer concept because in like the 1500s, that's when a lot of like the major astronomers and mathematicians at the time were starting to figure out like formal mathematics. Like calculus hadn't been created yet because that was Isaac Newton and Einstein were the ones who founded calculus, and that would have been later. I mean, Einstein, this weird thing is like Einstein was born in the 1900s. Like, a lot of people don't know that. He was like born like in the middle of like World War II. Like I always thought he was like ancient, right? You always hear about Einstein. No, he'd have been like your grandparents' age. Like that's really weird to me to think about that, because he's just so like famous. Like you think he's born a long time ago. He was in the 1900s. That's weird to me. But I mean, those are the ones who formally created mathematics, right? But yeah, but still weird, crazy systems. We still use them. I mean, they're used in GPS programs. They're used in everything we can possibly think of.
Do you think
Military
they used it
systems.
to do the pyramids?
What was that?
The pyramids? Do you think
No,
they used something
no,
like that?
they didn't do something like that. There's
So
no.
they used
You don't
aliens.
think so?
No.
Yeah, I'm pretty sure aliens.
All right, we're not gonna talk about this all as anything.
Aliens?
Not gonna happen. All right. Okay. Let's talk about the viewing windows. On a graph like this, when you're typing a calculator, to get the right view, so like the window that shows up here, so that if you're plotting some graph and you want to see what it's doing, it's called a viewing window. There's so many numbers, up and down, right and left, right, that you want to see on the screen so that you can see the graph, what it's doing. So on a calculator, and this is the part that a lot of people never see because they never have to use one, is there's this thing called the viewing window where it's the actual numbers involved with what the graph looks like. So for instance, this first thing has 3 numbers in it. What this is the scale, for the x-axis. So it's going to give you every number you need in 3 digits. And you type this in my calculator. So I'll show you probably tomorrow. I'll pull up a picture of my actual graphing calculator, and I'll show you like what you type, what it should look like. I'll actually have a camera right above my phone, and we'll project it right to the screen so you can see me live typing things in. And I want you to see it because it is kind of interesting the way it works. Okay, but the viewing window works like this. What is mine? Mine's -5 up to 5. So what this is the minimum x number. This is the maximum x value, and the number right here is what they're going to jump by. This is the actual gap or scale between numbers. So if you look at my graph, we start at -5, -4, and we're jumping by ones. Agreed? And I went up to 5. That's my viewing window. -5 up to 5 going by ones. I can go by halves. I can go by pi. If I could jump by pies. You can change that. And especially we'll change that when we start graphing trig functions, like sine, cosine, tangent. We actually graph those on one of these. So you can actually see what it looks like. And it's not just for triangles. There's actually wave theory and stuff that we talk about in this class. The second one is the y-axis scale. Well, how many numbers do you think are in there?
5.
3 numbers. Yeah. 3 numbers. The smallest number. What's my graph going down to? Looks like I went to -4. I mean, Caleb put it down to -5. He was actually probably pretty close to being correct where that's going to be. But if it's going by ones, it looks like my graph went down to -4. That's my minimum. That's the range, by the way. It went up to +4. And what was it jumping by? Ones? Put a 1 there. Jumping by ones. Questions on the actual viewing window? Now that's important because once you have your viewing window set, this is what it'll show. That's how zoomed out it will be. And then you can go from there. Then you can start doing tables, and you can set the plots, and you can start plotting points and stuff. Now here's the weird thing. Why I brought all this technology up. To change the viewing window, like on a phone or computer, you pinch and zoom with your fingers. when you pinch and zoom, right, it blows things up or makes them smaller, right? What you're doing with your fingers is changing that. So it's just blowing up those pixels to be bigger. So now it's changing your scale where it'll go down to negative number to positive number. It'll go by halves or ones so it can zoom in or out. It just changes the screen because it's just changing the window. So you're not going to all the pixels, you're just going to select few and it just like fills in the gaps. That's why when you use pinch and zoom, like older computers, it took a while. You pinch and zoom and it was like boom, 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 and kind of like chunk it out because it's trying to fill the pixels behind to make the picture look normal. That's why when you take a picture and you zoom in really far, it looks really bad. It's filling the pixels what it thinks the color should be in that correct spot because you're changing the viewing window. Instead of going the whole screen, you're going to the small portion and it's going to try to make it bigger and fill in the gaps so it looks smooth. Newer phones do it better. Well, hopefully newer phones do it better. Some don't. So and it's all based on the scale, what you're going by. Sometimes it won't look good because what you zoomed into isn't a nice clean number with the whole screen. It doesn't work out. That's why when you pinch and zoom, there's like these sweet points where it looks better than others because the numbers match. You can divide them out evenly. So, I mean, these are little things people don't think about that are in the background of like your technology. That's why it took a while for things to get to where they are. All right, I know that's a lot of weird, like geeky stuff for you, but I'm trying to talk about like practicality, like what we use it for nowadays. All right, we're done for the day. I said it was a light intro today, just kind of talking about the process of doing this. Tomorrow we'll be ready to go. We're going to go hot and heavy into it. If you want to take a retake, you don't need to tell me. Just show up and we'll start reviewing and we'll set a time for you to retake. I prefer that the retakes are done within 1 week. That way you're not forgetting stuff. I don't want to go 2-3 weeks out, you won't know how to do it anymore. It's already in chapter 1. Just show up. If you don't show up, I'm assuming you're not retaking.